Right, is my camera working yet? It looks like I'm live. I want to explain this because it's important, because there was a question, and I was scratching my head a little bit about this strange behaviour with my 3-coil generator project. I've actually fitted all the new coils now. They're actually in the unit. Now the 3rd coil, which is the exit coil, is at the bottom, and that's wired in series with the other two. The other two are in series, but the exit coil is wired inversely, which means that instead of contributing to the in an additive way to the waveform, it subtracts. So the exit coil subtracts from the waveform, and the first 2 coils are additive, which means that they're in series and they add more power to the output. Now, when the rotors are moving and the magnets are moving down in this direction, we normally have a drag effect, which is the length effect, which is what slows things down when you put a load on it. Now, something strange was going on, and I was trying to figure it out, and I think I sussed out what it is. But the actual exit coil is working, but it's working not in the way I predicted, but it's still working. I'll explain. Now, so we've got our 2 coils. Let's just draw it like this. Right. I'm trying to make it simple so it's easy to understand. Right. So we've got our 3 coils. Right. Now the first 2 coils are wired like this. So this coil is connected to that coil. So these 2 are actually contributing to the AC. So those 2 coils are actually wired like that. So these are generating power, and the power is in series with the exit coil, but the exit coil is wired like that, so it subtracts. So let's just put plus minus. So let's forget about the waveform right now, because it's AC. Let's just forget about the AC waveform. We're just interested in the actual behavior of the coil and how it works. So what happens is the rotor is moving. I'm not going to draw the rotor because it messes everything. It makes a mess, and then I can't erase it. So as the rotor's traveling, it first energizes the first coil, and then there's 3 magnets on the rotor. So then the first magnet is passing over the first coil. As that magnet moves, the first magnet is now over the second coil, but the second magnet is over the first coil. So we have both coils energized, which is generating our power. Now this power is also being sent through the exit coil, which is wired in reverse. So that instead of creating drag, this is basically creating suction or attraction. So whereas the first 2 are actually in equal opposite reactions, the 3rd coil is actually inversely attracting on the rotor. So no, it's actually repelling the rotor, sorry. So what happens is, as the first magnet moves past down to the 3rd coil, and we have basically the magnets then become basically 1, 2, 3 magnets, right? And they're all the same pole, they're all the same polarity. So the first 2 are energized, and the 3rd coil is actually starting to repel, because the more power is going through the first 2 coils, the greater the power through the first 2 coils, the greater the repulsion of the 3rd coil becomes. So what happened was, when I was loading this down through a circuit, I was seeing a drop in RPM, a small drop in RPM. But something strange happened, because what would happen was, on the initial introduction of a load, the RPM would drop, but then it would climb again. I thought, what's going on there? Anyway, I figured out, I think I know what's going on there. It's because it takes a while for this third coil to react and to actually become energized in such a way, and to also sync itself to the circuit, the load factor on the circuit. So once the load factors equalize out, the third coil starts to counteract that drag effect. So now let's look at it this way. So the first coil is now seeing the second magnet, right? The third coil is now seeing the second magnet. The second coil in this direction of flow is the second coil is now seeing the third magnet. So this coil now, the top coil, is now seeing a depletion, or it's no longer seeing the full flux effect. So what happens now is we have a slight offset in the way it works, because there's a slight delay in the reactance of the circuit. So we have this powerful flux being derived through the exit coil, which is actually is repulsing and pushing the rotor out of the way. So the rotor is actually moved out of the way instead of being dragged on and slowed down. So instead of the rotor slowing down, the rotor starts to accelerate away from the coil assembly when it's under load. So we see no reduction in RPM. But there seems to be it's all about this balanced situation, the amount of coupling between the coils and the rotor, and that's done by the amount of ferrite or steel that we put through the cores. That determines the amount of coupling that we have. So if we have more coupling on the generating coils, the first two coils, then we would possibly see more drag, unless we balanced it out with some equal amount of coupling on the exit coil, because the exit coil can only push back based on the amount of coupling it's got with the rotor. So if we generate more power on the generating coils, and we don't balance out the amount of coupling on the exit coil, then we're going to see more drag, more slowdown. So it's important that the amount of coupling is equalized across all three coils, so that it's proportional, so that we have, say, 40% coupling on the first coil. We could have 30% coupling on the second coil, but we need 40% on the exit coil as well, otherwise we won't balance it out properly. So I'm just giving you a rough idea on the way this is working. So that's what I was observing. So when I was testing this under load, I would see a drop of something like maybe 30-40 RPM. This is when we're spinning at something in the region of 8,000 RPM. So 8,000 RPM is pretty fast. And I was seeing a slight drop, but then it would start to pick up again. And I'm thinking, what's going on there? Well, that's because it takes a while for this to start to react, and we start to see the cancellation effect taking place on the exit coil. So one cycle, there's a massive kick when you first put a load on this. When you first load the coil down with a load, and the voltage just dips right down on the output of the coils, we see a massive drop in RPM. Well, not a massive drop in RPM. We say it's something like 20-30 RPM sudden dip, but then it picks back up again. And I was trying to figure out what the hell's going on. Why is it doing that? And I think I know what's going on. It's because on 1/2 cycle, when we're talking about half cycle, we're talking about just the south field passing this. If that load is introduced on just that south field, then we will see this sudden dip in speed. It's like a big sharp pulse that just slows it down. But once it's been established and this load is consistently there all the time, then whatever drag we see on the south field is compensated for by the north field when the magnets pass the north. So everything balances itself out. It's like it, I don't know how else to put it. All I can say is what I've been observing. What I've been observing is the initial loading of something seems to just knock the RPM down a bit, but it starts to climb back up again, but not as much as what it was before it was loaded down. So there is a slight loss. I am definitely seeing a slight loss, but not as much of a loss as what I would be getting if I didn't have this exit coil wired inversely. So anyway, I wanted to explain that because I think it's quite significant, because it's the way that I've designed my device to actually produce energy, and I'm hoping that as I get more coils added, which I've got some more to wind, as I get more coils wound, and I get a greater output voltage and a greater amount of current on the output, then I should start to see much greater deviations on what's going on. So it should be a lot more easy to analyze it and see what's really going on. Or I might be able to see more clearly if it's a complete flop and basically not doing what I'd hoped it would do. But we'll find that out as I go along. Anyway, I just wanted to record that so you could see. And I've got my concentrics added onto here now. I've got my 3 coil array underneath here. Let me just take the concentric off there. The ferrite's still on, but you can see the coils underneath. My exit coil is covered. I felt tipped it with blue felt tip pen so you could see the exit coil. So that's the exit coil on there, and I've got the other coil underneath. It's just the same. These are wired in series, so basically this wire is connected all the way through, and then the inverse coils are connected to each other at this back end, and then the circuit goes all the way back round, and that's where I'm taking my output round the two end at this end. So anyway, I've just got the other set of coils to wind. I've got one here done. I need to wind another 2, which I'm in the process of doing. And I'm going to fit that one in there, then wire these in series, and we can hopefully wire the whole lot in series with each other or in parallel. These are in series, but then we could have these in series parallel with those. So those would be in series too, but in parallel with these set. So we'll see anyway. Depends how I want to configure it really. And that's it. What's going on here? Come on. Stop.